Alright, here's our video for Unit 3, Day 4. You should have your own notebook paper. There's a lot of stuff I've already pre-written on my page that you're going to want to pause the video and write down, copy down on your paper. Pretty much exactly like I have it written down so far. There's a little bit more down here at the bottom that you'll come up to in a minute. At any point, if you need to go back and rewatch anything to get it copied down, you're welcome to do that, but please make sure you are listening to this video. Okay? It's very important to listen. Okay, so if you haven't had your headphones in or you haven't been listening yet, listen while you watch the video. It's not okay just to copy everything down. You're not actually learning. Okay, if you could copy everything down, you could just take your book home, use that, and I wouldn't be necessary. But I kind of like my job, so make sure you listen to the video. Make my job worthwhile. Please. Thank you. All right. This should verify that you are listening. You guys will come in talking to me about what I've just said if you were actually listening. All right. So let's take a look at Unit 3, Day 4. Okay, we are going to look at doing parallel line proofs, and we're going to use algebra to do that. We'll be doing algebraic proofs. You'll need all of those POEs, property of equalities, for solving these equations, but you'll also want to remember a couple things here. I want you to remember vertical angles theorem, that vertical angles are congruent. I want you to remember a linear pair theorem. If they form a linear pair, the two angles are supplementary. And I want you to remember the definition of congruence. If two angles are congruent, then their measures are equal. This is really important for the proofs we're going to do today. Okay? Now, good news is all the proofs we do will follow a pretty consistent format. But there are some theorems and postulates we're going to be using from this unit that are new. And so I want to talk about those first. Okay? So first of all, here's what we have. We have two parallel lines intersected by a transversal. And then we have these 8 angles. And we have these angle relationships that we've already talked about. We know what the relationships are. We've talked about the last couple days, but I'm just going to remind you what those are. Okay, first of all, the corresponding angles postulate says this. If parallel lines are cut by a transversal, then corresponding angles are congruent. Okay, for example, angle 1 is congruent to angle 5. All right? And all of the pairs of corresponding angles are congruent. Again, this is not new information. It's something we've been covering over the last couple days. Okay? Alternate interior angles theorem would say this. If parallel lines are cut by a transversal, then alternate interior angles are congruent. Notice I started abbreviating. That's okay. It'll save you some time. All right? Alternate interior angles are congruent. Now, there's a reason that this is a postulate and the rest of these are theorems. A postulate is a geometric concept or an idea that is so basic it doesn't have to be proven true. Now, the rest of these are theorems, and we could actually prove these theorems true based on this postulate, and things like the vertical angles theorem and linear pair theorem that we've just used. But we're not going to go through and have to do that yet. I'm just explaining to you the difference between postulate and theorems. These 3 are theorems. This one is a postulate. Okay, so if you haven't copied these down yet, again, pause the video to copy those down. All right? And then I'm going to show you the next 2. Okay, these next 2, alternate exterior angles theorem states, if parallel lines are cut by a transversal, then alternate exterior angles are congruent. And the last one is a little bit different. It says, if parallel lines are cut by a transversal, then consecutive interior angles are supplementary. Okay, so here's the conclusions we could have come up with. Here's your examples. Okay, back to corresponding angles, 1 and 5 are congruent, or 2 and 6, or 4 and 8, any of those corresponding angles have to be congruent. Alternate interior angles would be like 3 and 6. So here's your example that angle 3 would be congruent to angle 6 because of that reason. Alternate exterior angles would be like 2 and 7. Okay, because they're alternate exterior angles. But consecutive interior angles would be like 4 and 6. We would say the measure of angle 4 plus the measure of angle 6 equals 180 degrees because they're supplementary. Okay, and I'm kind of combining some ideas, but in general, that's what we could come up with. All right? So the next little bit of our notes are going to require us to do some examples. We're actually going to do a couple proofs using these ideas. So you might have room at the bottom of your page, but like me, you're probably running out of room. So you might want to flip to the back of this page for these next ideas. Okay, Okay, for both of our examples today, we're going to use this diagram. So go ahead and copy it down. Make sure you draw lines L and M that are parallel. Transversal T is a little bit of a downward to the left angle. It's not a huge deal, but for these proofs, it'll make sense when you see it. Transversal T. And these are your angles numbered like this. Make sure you number the angles in matching order to what I have. 1, 2, 3, 4, 5, 6, 7, 8. If you don't, these proofs will not make sense. Okay, so example 1, here's your given. We're told that L and M are parallel. That's what that symbol means. We're told the measure of angle 1 is this expression. It should be in degrees. And the measure of angle 5 is this expression in degrees. Okay? We want to prove that the measure of angle 5 then is actually equal to 106. Well, this is like the problems we were working on in the previous lesson, where I give you expressions. You can even write them in, okay, for any of those that you want to. And then we just solve them and find out what x is and plug it back in to find the angle measure. But we're going to do that in the form of a proof. We're going to justify all of our steps by those reasons, like theorems, properties, postulates, definitions. We have to give one of those reasons for each one of these, okay? So make sure you pause the video if you need to copy this down, which you probably should have done or you are getting ready to do. But once you're ready, go ahead and click play and we will proceed with our proof. Okay? The very first thing we always want to do on a proof is state the given, all right? I'm going to allow you to take a little bit of a shortcut. All right, we're going to do that. Okay, you don't have to write it all out, but these are the main ideas we want to use. The very next statement is going to have to be something that allows us to relate these things together so I can start to plug them in. I can't just write my equation yet. I have to come up with how I get that equation using one of these new concepts. So I want you to look at angles 1 and angle 5. 1 and 5 are a certain angle pair. You should notice they are corresponding angles. What we just covered in our video, the corresponding angles are congruent. So I can make that statement next. Because these are corresponding angles, I can say angle 1 is congruent to angle 5, and the reason is the corresponding angles postulate. Okay, and you can write that like that. Now you should be good at recognizing if these angles are congruent, their measures are equal. And that's just by the definition of congruent angles. Or definition of congruent. Now, this is where we can start to identify these equations. All I have to do is change this equation into the equation using the expression. So instead of angle 1, I put 2x minus 92. And instead of angle 5's measure, I put x plus 7. I want you to think about what allows us to take these out and put these in their place. Substitution. Okay, we're just substituting equal values in. Now we can start to solve the equation. Some of you guys are going to take different steps here. I would subtract x from both sides and get this. And that's the subtraction property of equality, since you're subtracting the same thing from both sides. Then I would add 92 to both sides. And you get x is 99. It's the addition property of equality. Okay, we're really close. We're supposed to prove the measure of angle 5 is 106 degrees. Well, I have the expression for angle 5 already, and I know x now is 99, so I can go back to the measure of angle 5, expression from the given, but instead of writing x plus 7, I can write 99 plus 7, again by substitution. And when you simplify this, we get our proof statement. The measure of angle 5 does equal 106 degrees. And our reason is simplify or combine like terms, but most of us will just write simplify. Okay? And so you've just done an algebraic proof using parallel lines and a transversal. We're going to do one more. Okay. I've just recopied that same diagram down here for example 2. You don't have to draw this one again a second time. Again, see, it's already the same thing up there. So just because it won't fit on the video screen, I went ahead and recopied it so we can look at it. But the given and proof statements are different now, so you do need to copy this down. Again, pause if you need to, otherwise we're going to proceed forward. We are given, again, parallel lines. That has to be established first. And this time we're told angle 4's measure is 6x plus 30. And angle 6's measure is 5x plus 18. So we're using 4 and 6 here. We want to prove the measure of angle 6 is 78 degrees. Alright, so that means we're going to have to go through like we did earlier, get some kind of equation to plug into, then solve for x, and then take that answer and plug it back in to show the measure of angle 6 is 78. Okay? Now, there are a lot of ways we could go about doing this, but you need to focus that we need to end up with this at the final part of our proof. Okay? So once again, we're just going to take all the givens, draw your arrow. You don't have to copy it down again. Right? Okay? That is just given to us. And now we can start to set this up. But in order to figure this out, this is where you guys are going to get lost if you're not listening. In order to get statement 2, you have to look at these two angles in the diagram and figure out what kind of angle pair they are. These, you should recognize, are consecutive interior angles. And from your previous page of notes, or from previously in the same video, we figured out that consecutive interior angles are supplementary, not equal, not congruent, but supplementary. Okay? So that's my next statement, is that the measure of angle 4 plus the measure of angle 6 equals 180, because they're supplementary, and I'm combining that idea of supplementary into this. And so our reason is the consecutive interior angles theorem. Okay? Because if they're parallel lines, consecutive interior angles have to be supplementary. Now I have an equation that I can substitute values into. The measure of angle 4 is instead going to be expressed as 6x plus 30. The measure of angle 6 is now 5x plus 18. And that should equal 180 degrees. All right? And that is just substitution. And now we can start to solve this equation for x. We first want to combine like terms or simplify. 6x plus 5x is 11x. 30 plus 18 is 48. Okay, we simplified, or you could say combine like terms. Okay, and then for the next step, we start to solve for x. We subtract 48 from both sides. And we get 11x equals 132. Again, that's subtraction, property of equality. And then we divide both sides by 11. And we get that x equals 12. Okay, again, that is not where we stop. We have to go back and plug it in to show that the measure of angle 6 is 78. So our next step is to express the measure of angle 6. But instead of 5x plus 18, we can write 5 times 12 plus 18. Again, we just substituted an equal value back in. And then we could combine these into one step, or you can list them as two steps. I'm going to just do it all at once. I'm going to do 5 times 12 plus 18 all in the calculator. Okay, and I'll even show you that. 5 times 12 plus 18. We do get 78. And so we can just write the measure of angle 6 equals 78 degrees because we simplified. All right? And that finishes our proofs with parallel lines and transversals using algebra.